Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is Lesson 3 for Algebra, Solving Systems Using Elimination. We want to solve systems by adding or subtracting, and sometimes we'll also look at multiplying first when solving systems. Okay. The elimination method is a method for solving a system of equations. Oops, let me get that down. Sorry. By adding or subtracting the equations to eliminate a variable. Okay, so let's just get right into it, as that's really probably the easiest way to explain what we're trying to do. Okay, this one is adding equations, solved by elimination. So when we look at our two equations, 2x plus 3y equals 11, and negative 2x plus 9y equals 1, we're going to eliminate 1 because the sum of the coefficients of, eliminate x, because the sum of the coefficients is 0. 2x plus negative 2x is 0. So right here, this gives me 0. 3 plus 9 is 12y, and 11 plus 1 is 12. We'll divide each side by 12 and solve for y, so y is 1. Okay, solve for the eliminated variable x by using either original equation. So in this case, we're going to choose the first equation. So we're going to substitute in 1 for y. So 2x plus 3 times 1 equals 11. So 2x plus 3 equals 11. We're going to then subtract 3 from each side. So 11 minus 3 is 8. So 2x is 8. Then divide by 2, so x is 4. Since x is 4 and y is 1, the solution is 4, 1. And then, of course, you check to see if 4, 1 makes the equation not used in step 2 true. So we go back to the second equation. So negative 2 times 4 plus 1 times 9. We want to know, does that equal 1? So we're going to substitute in 4 for x, 1 for y. Negative 2 times 4 is negative 8. 9 times 1 is 9, which equals 1, so it checks. So that way you're checking into both equations and less likely to end up with mistakes. So again, it's an idea of looking and finding things that are easy to eliminate, either by addition or by subtraction. Okay, let's go on to example number 2, multiplying one equation. Now sometimes what we'll do is we'll multiply so that we can more easily eliminate a particular variable. So sometimes that's going to be the case. Suppose the school band is selling cans of popcorn for $5 per can and cans of mixed nuts for $8 per can. The band sells a total of 240 cans and receives a total of $1,614. Find the number of each type of can. Okay, so we want to define our variables. P is the number of cans of popcorn sold, N is the number of cans of nuts sold. So first of all, P plus N, the number of cans of popcorn plus the number of nuts, equals 240. The total amount of sales would be 5 times P and 8 plus 8 times N equals 1,614. Eliminate one variable. So we'll look at our given system. We have P plus N equals 240. And 5p plus n equals plus 8n equals 1,614. To prepare to eliminate p, so we'll choose to do p, we're going to multiply the entire first equation by 5. So basically we place that equation in parentheses and multiply each and every term by 5. So we get 5p plus 5n equals 1,200. Then we see that both of these come out to be positive 5p. So we're going to subtract the equations to eliminate p. Back here, you could have also multiplied by negative 5 if you wanted to. So you have some options on exactly what you want to do. But in this case, we'll subtract. 5p minus 5p is 0. 5n minus 8n is negative 3n, or minus, and they already have the minus here, 3n. So do not put it in there again. If you want to make this a plus, then make it plus negative 3n. And this then is the difference between 1,614 and 1,200 is negative 414, because you're taking the larger away from the smaller. Okay, so we're going to solve for n. So negative 3n equals negative 414. Divide by negative 3. So n is 138. Because they're both negative, you don't want to you cannot have a negative value in the final answer. But by algebra, we see that when we divide both sides by negative 3, n becomes positive 138. So solve for the eliminated variable using either of the original equations. So the first equation's probably easier, and I generally try to use the one that I think is easier. I'm going to substitute 138 for n. So p plus 138 equals 240. So you're going to subtract 138 from each side, and p is 102. So the band sold 102 cans of popcorn and 138 cans of mixed nuts. Okay, so that's just a very simple run through on the idea that we're doing here. Eliminating a variable by adding or subtracting. We may need to multiply in order to have coefficients that cancel each other out or give us our zeros, eliminate down to zeros. Okay, so there is a quick check right here. But there is also another example, so we're going to move on to that one. Okay, sometimes we will even need to multiply both equations. Okay, so solve by elimination. 3x plus 5y equals 10, and 5x plus 7y equals 10. Okay, so we have our given systems right here. To prepare to eliminate x, multiply one equation by 5 and the other by 3. Okay, so which basically means we're going to eliminate the x. So the least common multiple of 5 and 3 is 15, so I'm going to have to multiply by 5. The first one by 5 and the second equation by 3. So I get 15x plus 25y equals 50, and 15x plus 21y equals 30. Subtract equations since they both came out to be the same. So 15x minus 15x is 0. 25y minus 21y is 4y. And 50 minus 30 is 20. So, whoops, I wrote 30, meant 20, sorry. Okay, so from there I'll solve for y. 4y equals 20, so y is 5 when I divide both sides by 4. Solve for the eliminated variable using either of the original equations. Again, the first one was chosen, but it doesn't really matter. We're going to substitute in 5 for y. So we have 3x plus 5 times 5 equals 10, or 3x plus 25 equals 10. Subtract 25 from each side, and we get 3x is negative 15. So x, divide each side by 3 now, and x is negative 5. So our solution is negative 5 for x, 5 for y. So the ordered pair negative 5, 5 is our solution. Okay, so you could basically add or subtract, and then you might need to multiply one equation or both equations in order to get rid of a variable or eliminate a variable. These examples all, looks like, as I recall, eliminated x first, but it's really your choice, and that might depend upon the numbers. So go ahead and do what you think is best on that. Okay, have all the quick checks ready for discussion in class. I'll be seeing you soon. Bye now.